in problem 5, we're asked to determine the infinite sums that are here. But in part A, I noticed that when I go from 32 to 28, that's subtracting 4. And from 28 to 24, that's subtracting 4. Meaning that this series is arithmetic. If we have an arithmetic series, there's going to be no sum. In the second one, as I go from 1/2 to 4, I'm multiplying by 8. And when I go from 4 to 32, also multiplying 8 by 8. Now we do have a geometric series. However, the common ratio being 8, it's too big. It's greater than 1. Each term is getting bigger. But that's going to mean that, again, we have no sum. When I look at part C, and it's the same thing as part B, but going the other way, we're not multiplying by 8 anymore. Now we're dividing by 8, which means we're multiplying by 1/8 from term to term. So our common ratio is 1/8. Since we do have a geometric series with a common ratio that's less than 1, there is going to be this infinite sum. And our formula tells us to find that sum, we're going to take the first term, 32, and divide it by 1 minus the common ratio, 1/8. Again, be very careful how you enter this into your calculator, and you should get 36.571. The exact value is going to be the 256 over 7. The last sequence that we have here is also an infinite geometric sequence, because to get from 0.5 to 0.05, we multiply by 0.1, just 1. And so also going from 0.05 to 0.005, we're getting another decimal place, so that would again be 0.1, meaning that our common ratio is 1/10. Obviously a value that's less than 1. So to find that infinite sum, we're going to start with the first term, 0.5, and divide it by 1 minus the common ratio, 0.1. This will be 0.5 over 0.9, which obviously simplifies to 5/9.